Good morning, class. These are our 6A notes, substitution. So substitution method is a method that many of you are already kind of figuring out on your own, which is pretty cool. So basically what we're doing is we're trying to substitute a number or an expression, something in for one of our letters, and we're going to solve that way. So for the first couple, we're just going to kind of play around with this idea. So I usually have students read this out loud, and we'll say y is equal to 3x. And because y is equal to 3x, that means we can substitute the 3x for the y in the other equation. So all we're doing for these first four is we're just circling an expression and the variable we could substitute for in each system. So on the second one, I want to look for the same thing. I want to look for an x or y with an equal sign directly afterward. So like the second one doesn't work. I have a 4x plus y and then equals 6. It's not just a y equals 6. I have something in front of it. But the first one, I have x equals this entire expression, y minus 1. So that's what I want to substitute. And because it is equal to x, I'm going to substitute it for x. So let's take a look at 3. Do we have an x or a y in front of our equal sign alone? So the first one, I have 6x minus 3y equals, so that one's not it. My x and y are together on that side of the equal sign. On the second one, I have y equals this entire expression, 2x plus 1. So that's what I'm going to circle. Because it's equal to y, I'm going to substitute it in for y. On my last one, x equals negative 3y. So the x is by itself, it's equal to that. And I'm going to substitute this for x. So now we're going to actually try to work it out and do the math. So for the first one, I want to, first I want to figure out what I'm going to substitute. If I have y equals 2x plus 5, let's go ahead and circle the 2x plus 5, and we're going to substitute that for y. So then I want to write down that equation. So instead of 3x plus y equals 10, instead of the y now, I'm going to write down that expression that I am substituting, the 2x plus 5, and then equals 10. So if you look at above, instead of 3x plus y equals 10, I have 3x plus 2x plus 5 equals 10, because all of this stuff right here is equal to y. So I've replaced it. So now to solve, I have to think about my solving steps. So 3x and 2x make a 5x plus 5. And then we're going to subtract 5 on both sides. 5x equals 5, divide by 5. So this is where your solving steps are going to be really important. If you're someone that's been kind of sloppy with your solving steps, it's going to make these a lot more difficult. So now I need to go back and find my second letter. So I have x equals 1, but I still need to find y. So I remember that y equals, according to this first equation here, y equals 2x plus 5. That means y equals 2 times whatever x is and then plus 5. But now I know what x is. My x is 1. So we can make that substitution. So 2x means 2 times x, but I'm putting in a 1. So now I have 2 times 1 plus 5. So let's multiply first. 2 times 1 is 2, plus 5 is 7. So my answer is going to be 1, 7. And then I just want to do a quick check on my work. So if I'm going to check, what I'm going to do is I'm going to check it in both equations. So my first equation was y equals 2x plus 5. So I'm checking, does 7 equal 2 times 1 plus 5? And I just used this one, so I know it's going to work. So it works in the first equation. And then I want to check my second equation. And so that one says 3x plus y equals 10. So 3 times 1 plus y, and y is 7 equals 10. 3 plus 7 equals 10. 10 equals 10. So my answer checks. I think it's important for us to talk about these answer checks, but I'm not going to have you do them on your own. It takes a lot of extra time, and sometimes this is where we make our mistakes. So we'll be working on practicing this stuff together, but not really on your own so much. So on the next one, x minus y equals 3, and x plus 2y equals negative 6. So what I notice on this one is I don't have a letter by itself. So I need to find one that's easy to solve for so I can force it into this substitution looking thing. So I need to find an x or a y that would be easy to isolate. So when I look at my second equation, isolating this 2y would not be easy. If I think about it in my head, I'd have to subtract the x over, and then I'd have to divide by 2. And I don't want to have to do a division step. So what I notice is in my first one, if I have x minus y equals 3, and I just add y on both sides, now I have x equals y plus 3. So again, when I'm adding that letter on both sides, it's really like I'm moving it, right? I can't really do 3 plus y. That doesn't add together. They're not like terms, but I've moved the y to the other side. So now I have something that I can substitute. I can substitute y plus 3, and I'm going to substitute that for my x over here. So let's go ahead and write that out. So we'll have y plus 3, and then plus a 2y equals negative 6. So I can put my like terms together. I have a 1y here and a 2y. That's going to make 3y plus 3. And then we will subtract 3 on both sides. Negative 6 plus negative 3 is a negative 9. Divide by 3. Y equals negative 3. Then I want to go back and find my x. Well, x is equal to whatever y is plus 3. And now I know what my y is. So x is going to be negative 3 plus 3, which means x is 0. So don't discount 0. I know there's been a lot of issues with that before. We solve and get a 0 where we think we're doing something wrong, but 0 is a perfectly good answer. So 0, negative 3. We're not going to do the answer check on this one. So for our last one, I'm in that same issue where I need to solve and get a letter by itself. So I have a positive y right here that's by itself. I kind of like the idea of solving for that one because I can solve for it by adding x. And anytime I can make minuses into pluses, I make less mistakes. So I could also solve for this x up here by subtracting 4y. But like I said, I really like if I can add something and make a minus into a plus, because now I have a positive x minus 2. I just make less mistakes. So let's go ahead and substitute that for y. And I'm going to write this out, and I'm going to do something wrong. And then we're going to talk about what I did wrong. So don't go too crazy writing stuff down yet. So it looks like I did everything right. I have x plus 4 times whatever y is equals 17. But I want to think about how 4 times y means 4 needs to be multiplied by all of y. And so this entire expression, the x minus 2, represents my y. But I want 4 to be multiplied by all of it. So right now, if I write 4 times x, I'm only multiplying it by the x. I'm not multiplying it by the 2 as well. So I need to have parentheses. I didn't need that up above because when I substituted here, I didn't have a number multiplying for that x that I was substituting for. And same thing in the first one. So let's go ahead and distribute. X plus 4x minus 8 equals 17. And I want to put a 1 in front, so I have 5x minus 8. We will add 8 on both sides. And then divide by 5. All right, last step is to find our y, so we can have an ordered pair. So y equals whatever x is minus 2. So y equals 5 minus 2. Y equals 3. So whatever we get here, we're always having to do like a second stage of substitution there where we find our second letter. So let's go ahead and write it as an ordered pair. 5, comma, 3. So this is substitution method. You do have one problem on the back to try on your own. Make sure you come to class ready to ask questions.